All right, we're going to go through the second part of dilations. And this part will get more specific into actually finding numbers of scale factors and kind of what kinds of numbers give you what kind of dilation. So we had started on page 66, and we're just going to continue that on today. So numbers that give us an enlargement. So an enlargement is making the figure larger by a scale factor and we'll kind of leave a blank there. This scale factor has to be greater than 1. Okay, 1.5, 1.1, 10, 12 over 2, or 12 over 7, something, any number or fraction bigger than 1. A reduction is making the figure smaller by a scale factor that is a scale factor between 0 and 1. So any number, fraction or decimal, between 0 and 1 will make the figure smaller. So like a fourth, a third, 33%. A lot of times you'll see that. They had a 75% reduction. Okay, that is a dilation going down. 75% is 0.775. So that would make it go down. So how to find a scale factor? How to find scale factor. The last lesson we talked about looking at the ordered pairs and seeing what you need to multiply. But for this one, we may not have ordered pairs. So to find the scale factor, you're going to take an image number divided by the pre-image number. I'll do some examples of that and we'll look at it. Okay, so let's say here that you're going to, well, let me just draw this out. So you've got this here, and then we're going to look at some shapes on this. Now this isn't a perfect drawing, but it'll give you an idea here. Okay, so we've got that shape, and let's say we're going to have this shape here. Okay, something like this. And on this shape, you have A, and A prime. So you have the pre-image and the image. But on this shape, you're also given the length of sides. So this side is 3, 2x, and this side over here is 10, 15, and 9. So before we had ordered pairs, now we don't have ordered pairs, we just have the length of how long the side is. So I can still find the scale factor using this formula here. And in this case, the scale factor, so the scale factor would be an image number, okay? So this is the so going here, we're going from this pre-image to this image. So we've got 15 over a pre-image number that goes with this would be 3. So your scale factor from the pre-image to the image going this way, so this is from A to A prime, is 5. Okay, it is getting larger. Your image is getting larger. Now, if I want to find X, which is right here, we're actually getting smaller, okay, because I'm going the opposite way. So if I want to look at the scale factor of A prime to A, we have to do this in the opposite direction or the opposite order. Okay, so if you want this first, it'll be 15 over 3. Or sorry, it'd be 3 over 15. So this scale factor would be 3 over 15, which would be 1/5. So going from here to here, you divide by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. 9 divided by 5, so x equals 9 divided by 5. That doesn't reduce, so we would just leave it. Okay, so you got to kind of look at what order you're going in. This scale factor will always be scale factor from pre-image, or I'll say from A to A prime. Oh, that shouldn't be there. From A to A prime, from the pre-image to the image. And there's one other thing we can look at, and that is a negative dilation. Okay, a negative dilation is a 180-degree rotation and follows the rules for enlargement and reduction. Okay, so a negative dilation is a little bit weird, and I'll do an example here. Let's say we're going to look at this rule. X, Y goes to negative 2x, negative 2y. Okay, so the negative tells us it's a 180-degree rotation. Okay, and the 2 means that I have a scale factor of 2, which means it's going to double in size. It's an enlargement here. So if I kind of draw this out, we're going to make a graph here. Okay, and I'll have a shape, kind of a small shape here. Here and maybe here. So we'll look at A, B, C. Okay, so over here, we're going to put A, B, C. C is at 1, 2, 3, 4, 5, 1. B is at 3, 2. And A is at 2, 1. So then we're going to multiply each one of those numbers by -2. So 2 times -2 is -4. 1 times -2 is -2. 3 times -2 is -6. 2 times -2 is -4. And 5 times -2 is -10. And 1 times -2 is -2. So we'll go and plot those ordered pairs. So this would be A prime, B prime, and C prime. Hopefully I got some room here to do that. So -4, 1, 2, 3, 4, 1, 2. That's A prime. -6. So 1, 2, 3, 4, 5, 6. -4, 1, 2, 3, 4. That's B prime. And C prime, so this was 6, 7, 8, 9, 10. 1, 2. C prime. So here is the shape. And you can see it rotated 180 degrees and it got enlarged. Now, the other thing we can look at here, I think I lost my ruler. Is we talked about connecting the image and the pre-image points. So if I connect A to A prime, okay, notice it went through 0, 0. If I go B to B prime, not much of a difference, but it goes through 0, 0. And C, you gotta make sure that you're on the actual point there. Here, and these would just extend forever in both directions. So that'd go that way, that'd go that way, and this would go this way, and this would go this way. This would go this way, and this would go this way. So you've got these lines in space, and you can draw a little two-dimensional shape in there. And when you have a negative, it goes through 0, 0, but then flips on the other side because of the way those lines are going. So these vantage lines or these viewing lines really help us to figure out what is happening. So a negative dilation, over here you have positive going this way. Between here and here would be some kind of fractional number. Even here to 1 would be a fractional number, but negative. And then once you go on the other side of this point of dilation, you have a negative dilation. I have put some more practice on Canvas for you to work on with dilations and actually finding the scale factor number. And then you'll be able to take the E.1 quiz for dilations. All right, and thanks for watching. If you got questions, feel free to reach out and ask, and then we'll see you in the next lesson.